Welcome to my channel Phi Concepts CHM. This is the fourth part of the series of Introduction to Optical Fiber, where we will see about the fractional refractive index and the numerical aperture. In short, we will call it as NA. Fractional refractive index. It tells us about the fractional difference between the refractive indices of core and the cladding. We denote it as delta. Delta is equal to N1 minus N2 upon N1. N1 is the refractive index of the core and N2 is the refractive index of the cladding. Now, always N1 is greater than N2. The refractive index of the core is greater than the refractive index of the cladding. That is a necessity for TIR, that is total internal reflection. So hence, as N1 is greater than N2, this fractional refractive index will be always positive, but then it will be always less than 1. Normally it is of the order of 0.01. Numerical aperture. In short, we will call it as NA. It is defined as a sine of the acceptance angle. Acceptance angles we denote as theta I max. So NA can be given as sine of theta I max. We had seen about the acceptance angle in the earlier video. It is the maximum angle that a light ray can have relative to the axis of the fiber and can propagate down the fiber. So if the light is launched into the fiber at this particular angle theta I max, it will be easily propagated through the fiber. We can write this as, we had derived this theta I max in the earlier video. It is given as sine inverse of square root of N1 square minus N2 square. So we can write down sine theta I max. From this equation we can write down sine theta I max. That will be equal to square root of N1 square minus N2 square. So that can be substituted. This sine theta I max can be substituted here. So we get the numerical aperture as square root of N1 square minus N2 square. Now we will consider this N1 square minus N2 square, which can be written as N1 plus N2 into N1 minus N2. Now we will multiply and divide this equation on the right hand side by 2N1. So we have multiplied with 2N1 and divided by 2N1. Now this ratio N1 plus N2 by 2 is approximated as N1 because the difference in N1 and N2 is very less. That is the refractive indices of the core and the cladding. The difference is very less. Like if, for example, the refractive index of N1 can be taken as suppose 1.46, and the refractive index of the cladding can be taken as 1.45. So you can see that the difference between both N1 and N2 is very less. So their mean can be written as approximately equal to N1. So we can substitute here in place of n1 plus n2 by 2. We will substitute here n1. So this is replaced by n1. Rest of the terms remain the same. Now n1 will get cancelled out, and what remains is n1 minus n2 into 2n1. Now we had just seen about the fractional refractive index. It is delta is equal to n1 minus n2 upon n1. So we can make a substitution for this n1 minus n2. What it will be? This n1 minus n2. You can get it from here. That is delta into n1. So that is written here. So that is substituted. So n1 into n1 will be n1 square. And you get 2n1 square into delta. So now we will substitute that in this numerical aperture formula. Na is equal to square root of n1 square minus n2 square. That means we will have to take the square root of this equation, square root of 2n square into delta. That will be, you have to just take the square root of n1 square. That will be n1 into square root of 2 delta. So the light gathering ability of a fiber hence depends on the numerical aperture. We can see that this formula contains this fractional refractive index. Also, if you use the earlier formula which we had seen in the definition, that the numerical aperture is the sign of the acceptance angle. So numerical aperture depends upon the acceptance angle and on the fractional refractive index. So the numerical aperture is a measure of the amount of light that can be accepted by a fiber. It depends upon the refractive indices of the core and the cladding. It does not depend on the physical dimensions of the fiber. The value ranges from 0.13 to 0.5. So if the value of the numerical aperture is large, that means the fiber accepts large amount of light from the source. Thank you for watching this video.